Decorators are functions used to do some pre-processing and post-processing to a given functionality in Python. So let's say the functionality is to display a message, happy birthday, wherein we will define greet birthday function and which will print happy birthday. Okay. So this greet birthday function is taking a parameter called name, and then it is printing happy birthday concatenated with that name. Now, if we want to highlight this output message, we will make use of decorators. Okay, if we want to do some kind of pre-processing or some kind of post-processing to greet birthday method, then we will create decorators. So now the next step is to define the method and try to use a decorator with it. How we are going to define a decorator, that we will see in the later part of the video. First, we will see how a function using a decorator is defined. Okay, and let me also add that there are two basic terminologies here. One is the decorator function and the other is the decorated function. Okay, so now we'll quickly see how do we define the function. We'll write def greet birthday, will pass in the name and then print happy birthday name. Okay, so here on the screen, if you could see, greet birthday is my decorated function. Okay, and at the top, at the rate highlight is mentioned. Okay, at the rate is a special symbol which tells Python that text following it is a decorator name. Okay, so here at the rate is followed by highlight, and highlight is a Python function that is a decorator that accepts greet birthday as an input parameter. Okay, so it also contains the code to pre-process and post-process the greet birthday and also invoke this function. Okay, so this is how I have, by writing at the rate highlight at the top of the function name, I have associated this decorator with this decorated function, telling Python that now the greet birthday function will be pre-processed and post-processed by the code which is dictated by the highlight. The way we mention decorator is quite similar to annotations in Java with different underlying implementation. Okay, but more or less the purpose of these annotations remain the same in Java as well. Now let's see the step 2 to define this decorator. On screen now is the highlight function which accepts the decorated function as the input argument, defines and returns a closure. This closure, called highlight message, invokes whatever function was taken in after doing the required pre-processing and also does the post-processing once the decorated function's invocation is done. Okay, so for pre-processing, we are just carrying a print statement which says pre-processing, and to represent post-processing, we are just adding a print statement saying post-processing. Otherwise, there could be chunk of code which can actually perform some kind of uh, utility services. For example, if there is a function um, call which needs to be counted, how many calls have went to the server. So in that case, you can write a similar code accordingly in the pre-processing part. Similarly, post-processing can also have its own chunk of code. But in order to simplify the example, I have just added the print statements. So moving ahead, so far we have seen how to write a decorator. Now let's study how the whole flow is integrated. Whenever a decorated function is called, Python invokes the decorated function passing in the decorated function. It obtains the handle to the closure and then it invokes the closure, and output of that closure is what you see on the screen. Okay, so it is mandatory for the decorator to have a closure defined, which returns the handle of the closure. Also, the same closure needs to invoke the decorated function from within its body. So this is an important criteria for the decorator to fulfill. Only then that function will be treated as a decorator. Let's take another example to illustrate decorators with a more practical use case. Let's write a program to calculate the area of a rectangle. I've defined the function rectangle area accepting length and breadth, and then I'm returning the product of the two as the area. Okay. Now here I am done defining the function name. Now I will define the decorator, which I'm defining here using the def keyword again because decorator is also a function name. So I'm writing def validate arguments. Decorated function would be my input parameter. So I'm writing decorated function here. The value of this decorated function would be rectangle area when we call this validate arguments as the decorator, right? So inside which now I'll be creating the closure. So the name of the closure is validate, which will take a list of arguments which are required to invoke the decorated function. Now we do not know whether the decorated function accepts a single argument or a multi arguments. So that's the very reason we will go with asterisk args, which is nothing but a representation of multiple arguments. Then inside this closure body, we will iterate over these arguments one by one. And we will say if arg is less than 0, which means that the argument, that is either the length or the breadth, is negative. Then we have to raise an exception or raise an error. So we will raise value error and we will say input arguments cannot be negative. Okay, and then finally we will return the handle of the closure. Okay, so we will do return validate, right? But so basically here is the pre-processing that we are doing, right? We are calling this closure validate, and then we are checking the arguments if those arguments are negative or positive, and then if there is no error, right? If the input dimensions are positive, then we are going to invoke our decorated function, right? So this is the step that we missed out. So let's write that step here. Okay, so we will say return decorated function, and inside which there would be args. Okay. There would be star arcs. And then finally, we will say return validate. So now, since we have defined the decorator function, we have defined the decorator. Now our step is to associate these two with each other, which will be done by writing this annotation at the rate validate arguments. Okay, now let's try to run this code and see what happens. But before that, let's make a call to the decorated function so that our decorator is invoked by Python. So we will say print the area of rectangle is rectangle area 10 comma 30, and we get the area of the rectangle is 300. So this output we are able to get when we pass the positive numbers, right? But let's check the scenario when one of the arguments is a negative integer. So I am making it minus 30, and now when I run this, we see, as expected, the code has executed correctly and there is a value error thrown by the decorator, and this code works perfectly fine because this is exactly we wanted the rectangle area to be executed successfully only when the arguments are positive numbers, right? So this decorator that we have defined here can also be associated with multiple decorator functions. Let's say if we have to calculate the area of a square, let's say. So we will write def square area side, right? And then return side into side, right? This is another function that I'm creating and I am associating it with the same decorator function validate arguments. Okay, there is no need to define the validate arguments again because it's already defined above. We are just going to associate this with square area function, and then we are going to call the square area function in a print statement like this. So if I give just 10 and run the piece of code, we get the area of square as 100 because we passed on the side as 10 units. Right now, if I just try to, I'll just comment out this statement for now and I will just run this with a negative value. And yes, as expected, we see we are getting this input arguments cannot be negative error. This is what exactly the code has done for us. Okay, it has thrown this exception because the input argument passed was a negative number. We would wrap up the video here. If you have any queries, please leave them in the comment section below. We'll be happy to answer them. If you found the video useful, please like it, subscribe to my channel, and I will see you in my next video.